We're going to talk about reflections and glide reflections today. So reflections, the objective is to transform figures using reflections and glide reflections. There's the standards. So by definition, a reflection is geometric figures that are symmetric with respect to a line. Now we talked about symmetry last time. It's like when there's a mirror image across a line. Okay, so a reflection with respect to line L is defined by describing both the location of the image of each point of the plane as follows. If A is a point on line L and A equals A prime, then the point is not going to, it's its own image. It's a fixed point. If A is off of the line L and we reflect, which is in most cases, then, all right, L is a perpendicular bisector of A prime. So if I had A, right, and I need to reflect it, I would construct a 90-degree line. I could do it with the smile, right? I could make my smile in an X, draw the perpendicular, and then I would just make it the length, this same length, right? I'd measure the length from O to A, and I'd make it go out the same length to reflect it. So in example 9.4, describe the image of A, B, C, and a reflection with respect to the line L as shown. Alright, so what you're going to do, let's see what I have in your notes. Yeah, okay. So on B, you want it to end up looking like C. So on line B, you need to do that 90-degree construction. Okay, so go ahead and do that. Get out your construction tools. Practice it so you can do it. If you need tools, I've got some you can borrow up here. Just bring your ID. Again, how you construct the 90-degree is you do A, you make the smile, smile from A, and then X, and then we draw the line, and I measure this distance, and I duplicate it here. That's where I know where A prime is. I do that for each point. So after you've made your smile, measure the distance from A to P, and then double that. That will be your distance from A to P prime. You do that for each point. Anybody need help with the process? Everybody got it? Ready to go on? Okay, so that's reflecting across a line. It appears that A prime, B prime, C prime is congruent to ABC. Also notice that while the orientation of ABC is clockwise, when you reflect it, the orientation of A prime, B prime, C prime is counterclockwise. So a reflection does not preserve orientation. Properties of reflections. Reflections take lines to lines, rays to rays, and line segments to line segments. They preserve distance. They preserve angle measure. They preserve perpendicularity. And they preserve parallelism. So the same five as the others, except the one thing they don't preserve that the others do is, that we've talked about so far, are orientation. Notice that AB is not parallel to A prime, B prime. Therefore, reflections are similar to rotations in that the image of a line of symmetry of a line is not necessarily parallel to the original line. We observe that ABC has a clockwise orientation and A prime, B prime, C prime has a counterclockwise orientation. Thus, reflections differ from both translations and rotations since orientation is not preserved. The glide reflection. Consider the footprints in the sand. This is an example of the final type of transformation. Okay? It's impossible to translate or rotate the left foot to the right foot since they have different orientations. Also, we cannot find any reflection line to reflect one foot onto the other. So it's saying, you definitely can't use it. If you had this line right here, you reflect it across that, you still would not get a reflection of this onto that. Right? So, what we can do is perform a combination of a reflection and a translation. So we reflect across the line and then we translate forward. That combination is called a glide when the translation is the glide part, and reflection across the line. That's a glide reflection. So footprints in the sand are a glide reflection. Definition. Glide reflection is a reflection followed by a translation that is not the identity translation. The identity translation wouldn't move the figure at all. It'd stay in the same place. Properties of glide reflections. Glide reflections take lines to lines, rays to rays, line segments to line segments. They preserve distance, they preserve angle measure, preserve perpendicularity, preserve parallelism. Okay? The same five for all four types. The only thing that is not preserved is orientation. Okay, they don't have that listed, but that's the difference between the two reflections and the rotation and the translation. The first two do preserve it. The reflections do not preserve orientation. So we've got an example here we're going to do a glide reflection. We've got triangle ABC. All right. The first thing in the axes in the middle on axis B. Okay, we're going to do the translation. So translate the vector for translation is 0, 0 to 0, 2. So that's telling us that, what is that telling us? If the translation from 0, 0 to 0, 2. That tells us we're going to translate along this vector, 0, 0 to 0, 2. That's the vector of translation. So I'm going to apply that to each of these points, right? It's 2 down. 2 down here, 2 down here, and 2 down from B, right? Go ahead on the middle graph, on the graph B, go ahead and do the translation of 2 down to get A prime, B prime, C prime. When you get done, it should look like the figure B I have up there. All right. So now, the second part is a reflection from reflection in respect to the y-axis. So this is the y-axis. To reflect with respect to the y-axis, if A prime is 1 over, so this distance from the y-axis to A prime is 1, right? It's 1 to the right. So if we reflect across the y-axis, we would go 1 to the left. That would tell me where A prime is. You don't have to measure it, just use the tick marks on the graph. B is 2 over, right? Or B prime is 2 over from the y-axis. So we'd go 2 over this way on the y-axis. We'd get B prime. And so on. So you do that for each point. Should end up looking like what I have in C. So make a reflection across the y-axis. Now, something that you'll have to do that I'm seeing that some of you didn't do is you have to make sure that you do label these, like after your first step, label these new points A prime, B prime, C prime, and then when you reflect A double prime, B double prime, C double prime. So when I grade it, I can see exactly the order and what you did. Right? So you need to have all 3 triangles labeled with A, B, and C, and the appropriate number of primes after. Everybody got it? Anybody? Yep.
You add prime each time you rotate, reflect, or something like that.
Yeah. You add the primes after you translate, then you add the primes after you reflect. So if it's multiple steps, you should have two sets of, you should end up with double primes. All right, so now you can refer to the figure. What is the point, the image, or the A double prime of A? What points did we end up with? What's the coordinates of A double prime? Shatiz.
-1, -2.
-1, -2. What's the image of B double prime, Adhicha?
-2, 1.
-2, 1. Okay. C double prime, go ahead.
-5, -1.
-5, -1. Okay, so now if we were to generalize with variables S and T, in terms of S and T, what is the image going to be? Look up above for a pattern. What's happening? Jordan.
Is it -S, t minus 2?
Yes, -S, t minus 2. If you look above, when you go from A to A double prime on your x values, they're always just changing the sign. So that's how she got -S. And the t minus 2, if you look at A, from 0 to -2, I'm subtracting 2. From 3 to 1, I'm subtracting 2, and so on. All right? Okay, any questions there? In each case, the y-coordinate of the original point is decreased by 2 because of the downward translation. The x-image point coordinate of each image is the opposite of the pre-image. That's just explaining what we just did. All right, any questions on the notes?